the key thing is that there needs to be some understanding of the disease, the pathophysiology of the disease, and there needs to be a strategy whereby the introduction of a new sequence or the modification of a sequence in the genome upon that modification is going to remedy the circumstance. If it's something that's missing, if it's a protein that's missing that causes disease, that's a pretty straightforward kind of thing. You do still need to have a mechanism for delivery. So that's one of the big challenges, is getting it to the right place. It's getting things into the liver is a lot of things go to the liver, so that's something you can do. You can do ex vivo into hematopoietic cells, but if you need to get something into the brain, then that's going to be more of a challenge. And the more complicated the disease is, then it becomes more of a complex thing in terms of coming up with a strategy. If you take the example of autism, you would have to have some sort of a strategy whereby if you change something or express something, then that's going to have a beneficial outcome. I'm not sure that there's anything out there for that case. A lot of people are working on diabetes. The advent of GLP-1 and alternate approaches to peptide expression, for example. People are looking into. There's a lot of research going on in that case. I've heard of a new therapy recently that is having some promise for Huntington's disease. This is an odd kind of disease. Is caused by unstable DNA sequences that expand, and so they have a potentially a methodology that's going to work for that. So it depends on what the molecular mechanism of the disease is and how you might be able to impact upon that.